Today we will be discussing about median and mode for both grouped and ungrouped data. So let's start with median. So median in simple word is that value which divide the entire data into two equal halves, right? So if the value of median is, let's say, suppose m, then there will be exactly 50% data below m and exactly 50% data above m, right? So that particular value which divides your 100% data into two equal halves, 50%, 50%, that particular number or value is called median. So for ungrouped data, if your values are x1, x2 up to xn, then median will be dependent on the number of observations, whether your number of observations n is odd or whether your number of observations is even, right? Odd means 1, 3, 5, etc. So if your number of observations are odd, then it is quite simple to calculate median. It is the middlemost value. But in case of even numbers, the median is combination of the two middlemost values. So for odd number of observations, median is equal to value of the n plus 1 divided by 2 at observation, right? And for even number of observations, median is equal to value of n by 2 at observation plus value of n by 2 plus 1 at observation divided by 2, right? So there are two different formulas. One is for odd number and one is for even number. So for odd number, it is quite easy. If you have, let's say, 5 observations, then median will be 5 plus 1 divided by 2. That means third observation, right? Similarly, if you have 7 observations, then median will be 7 plus 1 by 2. That means fourth observation. So let me give an example which will clear these two things. So let's say our observations are 10, 6, 8, 2 and 5, right? So these are the values, right? Now we are to find out the median. So to find out the median, the first step is you have to arrange them in increasing or decreasing order. So in increasing order, the values will be 2, 5, 6, 8 and 10. So this is step 1, okay? Step 1, arrange them in increasing or decreasing order. Then step 2, count number of observations. So here we have 1, 2, 3, 4, 5 observations. That means odd. So in that case, we need n plus 1 divided by 2 at observations, right? So we have 5 plus 1 divided by 2. So that means 6 divided by 2. That means third observation. So median will be the value of the third observation. What is third observation? 6. So median will be 6. Now see, this value, this particular value 6 divides the entire data of 5 into 2 equal halves. There are exactly 50% below, 50% above, excluding the median value, right? 50% below, equal number of observations below the median, equal number of observations above the median. Now this is for odd number. Now if you have even number of observations, let's say the values are 10, 6, 2, 3, 8 and 15, right? So step number 1 is always arrange them in increasing or decreasing order. So in case of increasing order, the values will be 2, 3, then 6, 8, 10 and 15, right? So that is step 1. Step 2 is count the number of observations. So n is equal to 6. Step 3 is in case of even numbers, your median will be, you have to find out the n by 2. So value of n by 2 at observation, which is n by 2 means 6 by 2 is third observation, right? Value of n by 2 plus 1 observation. Now n by 2 is 6 by 2 plus 1, that means 3 plus 1, that is fourth observation. Now third observation is 1, 2, 3, that means 6. Fourth observation is 8, so this is 8, right? So median will be the average of these two values. Median will be 6 plus 8 divided by 2, that means 14 by 2 is 7. Now see, the value 7 lies here, right? 7 will be here. So there are exactly 50% below, exactly 50% above. So that is how we calculate median for even number of values. So odd numbers, simply find out the middlemost term. Even numbers, you have to take the average of the middlemost numbers. That's all. You don't have to even write down all the steps. You just have to find out the middlemost term, right? So that is median for ungrouped data. Now let's see what happens if you have group data. That means you have values and their corresponding frequencies, right? Let x1, x2 up to xn are n observations, right? So they have certain frequencies with frequencies f1, f2 up to fn, right? So in that case, median is equal to, we have to find out median using the formula value of the n plus 1 divided by 2 at item. Which is, let's take an example. So we have values of x and their corresponding frequencies f. So 5, 10, 15, 20 and 25. And the frequencies are 2, 5, 12, 14 and 15, right? So here we calculate something called cumulative frequency. So cumulative frequency is, you have to add the successive frequencies, right? So the first thing will be 2, So first thing will be the same frequency, then you will have to add the next one. The value will be here. 2 plus 5 is 7, 7 plus 2 is your 9, 12, and then this would be equal to 33, this would be equal to 48. So these are called cumulative frequency. So you will have to keep on adding the frequencies at every step, right? So now the last value of the cumulative frequency, or the total of this particular column, is denoted by capital N, which is 48. Remember that this value and this value will be always same. The last value of your cumulative frequency should be equal to your total frequency, right? So this is your value of x, 5, 10, 15, 20, 25. 5 was repeated twice, 10 was repeated 5 times, 15 was repeated 12, 20 was repeated 14 times, and 25 was repeated 15 times. So these are the cumulative frequencies that we have calculated. What are the values? 2, 7, 19, 33 and 48, right? So now we will find out what is n plus 1 divided by 2, right? So n plus 1 divided by 2 will be 48 plus 1 divided by 2, that means 49 by 2, which is equal to 24.5, right? So now this is the value of n plus 1 divided by 2. Now median says that the value of the n plus 1 by 2 were term. Now obviously 24 plus 5 term does not exist. So we will have to find out something greater than 24, right? The cumulative frequency which is greater than 24.5. So 24.5, the cumulative frequency is 33. So the median will be the corresponding value of x. So median is equal to 20. So let me rewind the process again. There are values with their number of frequencies, right? So the only step is to calculate cumulative frequency. Cumulative frequency is nothing but adding the frequencies every time, right? Every successive frequency you have to cumulatively add them. The first one will be the same, second one, then this. So diagonally you will have to keep on adding them. Another thing to remember is total frequency will be the last value of the cumulative frequency. So once you get the total frequency and cumulative frequency, you have to find out n plus 1 divided by 2, right? So here in this case n plus 1 divided by 2 is 24.5. Next, in this column of cumulative frequency, find out something which is just next to 24.5. Now 19 is always obviously less than 24.5, 33 is greater than 24.5. So this is the value that we are looking at. So the corresponding value of the x will be your median, right? Now this is the process for finding out median if you have only value of x and corresponding frequency. That means discrete grouped data. Now we will look into the example of finding out median when you have class intervals, right? In case of continuous grouped data, median is equal to L plus n by 2 minus 1, n by 2 minus fc by f into h. Here L is the lower limit of median class. N is total frequency, H is class width, right? F is frequency of median class, frequency of median class, and FC is cumulative frequency just after median class, right? So the different terms or different symbols have different meaning. This L is lower class limit, N, this capital N is total frequency, this H is class width, this F is frequency of median class, this FC is cumulative frequency just after the median class. Okay. So let's try. Sorry, one correction. This is just before the median class. Okay. This one just before median class. Let's take an example. Okay. So the example has certain class limits of marks, right? And then we have frequencies. So the class limits are 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100, right? So there are 5 students who scored marks between 0 to 20. There are 15 students who scored marks between 20 to 40. There are 30 students who scored marks between 40 to 60. 12 students scored marks between 60 to 80, and 8 students scored marks between 80 to 100. So if I add this will give you 70, right? That means this is total frequency. Total frequency is 70. That means the situation is in a class there are 70 students, right? So they were subjected to a examination of 100 marks. So after the evaluation of the answer script, the teacher found out that there are 5 students who scored marks between 0 to 20. There are 15 students who scored marks between 20 to 40. There are 30 students who got marks between 40 to 60. 12 students who got marks between 60 to 80, and 8 students scored between 80 to 100. Now we want to find out the median of this data, right? So in this situation I am interested in finding the median. So to find median, the very first step is to calculate cumulative frequency. So we will denote it by CF in short. Cumulative frequency. What is cumulative frequency? The first value will always be same. That means first line it will be the same. Next line, let me use a different color. So next line you will have to go down diagonally and add the value, and the result will be written in the next line. Similarly, go there, write the answer, go diagonally, answer here, go diagonally, answer here, right? So 5 plus 15 will be 20, 20 plus 30 is 50, 50 plus 12 is 62, 62 plus 8 is 70, right? And as I have already mentioned, the last value of this cumulative frequency should always match your total frequency. If these two things are not matching, that means you have made some mistake in this calculation of cumulative frequency, right? So we have calculated cumulative frequency. So that is step number 1, finding out your cumulative frequency. Step number 2 is finding out n by 2, right? This is step number 2. So n by 2 here is 70 by 2, which is 35. So this is step number 2. Step number 3 is finding out the median class. So as I have already stated the formula, right? This is the formula. Here you see that we have used the term median class, median class, median class quite often. That means all of these terms are dependent on something called median class. So what is median class? Median class is that range out of all this range, right? So in this case we have 5 different ranges: 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. So these are range or class intervals. So our first objective is to find out a probable class interval within which we assume that the median will fall, right? So that probable or suspected class where the median is supposed to be falling is called median class, right? To find out, we take help of n by 2. Now in this example, the value of n by 2 is 35. So once you get n by 2, next thing is to look into the CF column, that means cumulative frequency column. You have to identify a class which is greater than 35, right? Which is just greater than 35. So 5 is less than 35, so rejected. 20 is less than 35, so rejected. 50 is greater than 35, so this is the median class. So this over here will be your median class. You don't have to write all this. This is just for your understanding, right? So 5 is less, rejected. 20 is less, rejected. 50 is greater, so it is accepted. And the question is 62 is also greater, 70 is also greater. Then why we are not choosing them? Because 50 is the just next value in the cumulative frequency table, right? You just have to find out something which is just crossing the value 35, right? So 50 is the first value that comes in that series. So this will be your median class. Now once you have identified, so this median class, this is your step number 3, right? Once you have found out the median class, you have to identify all the different values used in the formula. So what is the formula? Median is L plus n by 2 minus fc by f into h. So you will have to find out L. Now n by 2 we have already calculated. Now our task is to find out L, F, FC and H. So here in this median class, what is the lowest value? This will be called your lower class limit of the median class is L, right? This is your L. This value over here for this F will be our F, right? So this is L, this is F, and the value just before your median class, right? This value is your FC, fine. So this is your L, this one is L, this one is F, this one is the before is FC, and the difference between these two values, the class difference, that means the lower limit and upper limit, the difference between them is called your H, right? So in this example, L is equal to 40, right? F is equal to 30, FC is equal to 20, this is FC, FC is equal to 20, and H is equal to, the difference between 40 and 60 is 20, right? So these are the values. And what is n by 2? N by 2 is 35. Now this is just a matter of replacing these values into this formula. So median is L is 40 plus n by 2 is 35 minus FC is 20 divided by F is 30 into h is 20. So 40 plus, this is 15 divided by 30 into 20. So 40 plus this 2 is 10. So that means our median is 50. Now see, the median value is 50. 50 is exactly between this 40 and 60, right? 40 and 60, it lies within this limit. So we expected that our median will lie between 40 to 60, right? And we found out that our median is 50, which obviously lies between 40 and 60. So our median is correct. This is one way of verifying your calculation. Suppose replacing the values and simplifying, you found out the median to be 65, and you assume that the median class is 40 to 60. Now 65 is greater than 60, it does not belongs to this range. That means somewhere you have made a mistake, right? Your calculations is wrong. So this is how we calculate median. Let us get another example which will clear doubts if you have any in the calculation of median, right? So here we have an example where we have 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. These are the class intervals, and we have certain frequencies. What are the frequencies? 3, 5, 9, 3 and 2. These are the frequencies. You can assume that this is a class test of 50 marks, and these are the number of students who scored marks between these different ranges, right? So what is the first step? We will have to find out CF and total frequency. Now total frequency will be here, in this case 3 plus 5 8, 8 plus 9 is 17, 17 plus 3 is 20, 20 plus 2 is 22. Now we need to calculate cumulative frequency. The first thing will be 3, 3 plus 5 is 8, 8 plus 9 is 17, 17 plus 9 is 20, 20 plus 2 is 22, right? So this is our first step. This is our second step. Next is finding out n by 2. N by 2 is 22 by 2 is 11. This is your next step, right? Here n by 2 is 11. So this is how we write down the solution. Okay, solution of a median example. So first line you will have to write down: for calculation we construct the following table. Okay, this is your first line in the solution. Then you will make this table, that's all. Then you will write here n by 2 is equal to 22 by 2 is equal to 11, right? The cumulative frequency just greater than n by 2 is equal to 11 is, what is the value? Obviously 17, right? 3 is less, 8 is less, 17 is more, is 17. Therefore 20 to 30 is the median class, right? So this is how you will write the solution. Here n by 2 is equal to 22 by 2 is 11, right? Which is the next value. Preceding this is 17. Therefore the median class is this, right? Now L is the lower class limit. So this, now anything in yellow you are not supposed to write in examination. This is for just explanation. You don't have to mark this median class, right? You don't mark this. This is just to explain. This will be your median class. This value over here will be your L. This value over here is your F. This value over here is your FC, right? The difference between them is 10, which is your H. That's all, right? So we will write here now L is 20, H is equal to 10. 10 is 30 minus 20, right? 10. F is equal to 9. This is 9. And FC is equal to 8. 8 means the cumulative frequency is just less than your median class, or before, the one before your median class, right? Now, or therefore, median is equal to, what is L? It is 20 plus, let me write down the formula. Median is L plus, or you can write it thus: the median is equal to L plus n by 2 minus FC by F into H is equal to, what is the value of L? It is 20. N by 2 is 11. What is the value of FC? It is 8. What is the value of F? That is 9. Into H. What is the value of H? That is 10. Right? So if you solve this, you will get 20 plus 3.33, which is 23.33. Right? So this is the median. Now the value 23.33 obviously lies between 20 and 30, which is the assumed class of median, right? Or the range within which our median will lie. That means we are within the range. That means our calculation is correct. So median is equal to 23.33. So that is how we calculate median. Now let's move to another formula or another measure of central tendency, which is called mode. Okay. Mode represents the highest frequency or the number which is repeated most, right? So that is mode. Mode means nothing but something which is repeated the most number of times, right? So for ungrouped data, mode is finding out that value which repeated the most number of times. So for example, if the values are 2, 2, 3, 2, 3, 2, here 2 is repeated 1, 2, 3, 4, 4 times, right? And 3 is repeated 2 times. Now 2 is repeated highest number of times, therefore mode will be equal to 2, right? But there may be situations when, if the situation is like this, 1, 2, 3, 1, 2, 3, right? So in this case 1 is repeated 2 times, right? 2 is repeated 2 times and 3 is also repeated 2 times. So we cannot distinguish or we cannot identify someone which is repeated most number of times, because everyone is repeated equal number of times. In such a case, mode will be 1, 2 and 3. That means all of them will be mode. So that is one property of mode that you should remember, which is mode is not unique. So unlike arithmetic mean, harmonic mean, geometric mean or median, which always give you a single value, mode is not like that. Mode can be more than one value, right? So in this example we have three values which are repeated highest number of times. So there are three modes. There may be situations when there will be two numbers which is repeated most number of more number, so they will have two modes, right? So if you have only one mode, that is those kind of data is called unimodal. If you have two modes, then it is called bimodal, right? This example over here is called a trimodal data. And if you have more than three and multiple modes, then it is called multimodal data. So we will not go to that, but simply remember, if you see somewhere that the data is unimodal, if you hear this word unimodal, that means there is only one thing which is repeated most number of times. If it says it is a bimodal, that means there will be two items which is repeated most number of times, right? So this is mode for ungrouped data, where you have only simple numbers, then just count the value which is repeated most number of times. That will be your mode. Now in case of discrete group frequency data, say for example, if you have x and corresponding frequencies, let's say 2, 4, 6, 8 and 10, and 2 is repeated 3 times, 4 is repeated 5 times, 6 is repeated 11 times, 8 is repeated 21 times and 10 is repeated suppose 5 times. So this is a discrete group frequency table. So here mode will be that value of x for which we have the highest frequency, right? So mode will be that value of x which has highest frequency. So in this case, 3 out of 3, 5, 11, 21, 5, obviously 25 is the highest, right? So what will be the mode? Mode will be equal to 8, right? That means the value 8 has been occurred the most number of times, so it will be your mode, right? So that is for discrete. Now what happens for grouped class interval? For continuous grouped data, mode is equal to L plus f1 minus f0, 2 times of f1 minus f0 minus f1 into h. This is the formula for mode if you are dealing with continuous group data. That means if you have class intervals and frequencies. So here L, same like median, it is the lower class limit of the model class. Model class. A model class means same like median class. Here also we will have to find out a class interval where we are suspecting that the mode will fall, right? So in this case, finding out the model class is quite easy. Now L, H, same like median, is class width, right? This is class width, same like. Now we need to find out what is f0, f1, f2. This is frequency before model class. This is frequency of model class, right? And this is frequency after model class, right? F0, F1, F2. So the order 0, 1, 2 is also helpful in finding out or in remembering this, right? 0, 1, 2. 0 means before, 1 is the exactly model class, 2 is the next one, right? So if we do an exercise, that will clear up. So let's take the same example, which is 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. And the class frequencies are 5, 15, 30, 12, and 8. So this is your data, and you are supposed to find out the mode. So solution. Here the maximum frequency. Now what is the maximum frequency? Maximum frequency is 30, right? Here the maximum frequency 30 is associated with the class interval. The class interval is 40 to 60. Therefore, the model class is 40 to 60, right? So this is how we start the solution of a mode problem. Now this marking down the class interval is not necessary. This is just to explain, right? So this is class interval, this is F. Now we found out the model class using the maximum frequency. Now we have to find out, here. Now what is the formula for mode? Mode is equal to, or you can write here also, let's write in a systematic order. After this, write down the mode is given by mode equal to L plus F1 minus F0, 2 times of F1, F0, F2 into H, right? Then write down here what is L. L is the lower limit. So in this example, this is your mode class, right? This is your mode class. So the lowest value will be your L. This value, this is the frequency, right? These are all frequencies. Frequencies of the model class is F1, right? 1, remember 1. And the before this is F0, and the next one is F2, and the difference between them is 20, which is H, right? So these two things, these are same for median and mode, finding out the lowest class limit and the difference between them. Okay, that is same for median and mode. Only thing different in mode is, remember this, the class value, the frequency of that class, 1 before, 1 after. The sequence is 0, 1, 2. Remember 0, 1 and 2, right? So here L is 40, right? The difference between them is 40 and 60 is 20. So what is F0? F0 is 15. What is F1? F1 is 30. What is F2? F2 is 12. right? All. This is all we need to calculate mode. Therefore, mode is equal to L is 40 plus F1 is 30 minus F0 is 15, okay, divided by 2 times of F1. F1 is your 30 minus F0 is 15 minus 12 into what is H? H is 20. Now if you solve this, this will be 40 plus this is 15 and this will be equal to 33, right, into 20. So this 40 plus 9.09 is equal to 49.09. Now 49.09 obviously lies between 40 and 60. So that means our calculation is correct. Therefore, mode is equal to 49.09. So that is how we calculate mode for discrete data, for discrete group data, and for continuous group data. For continuous we use formula, right? So this is the formula to find out mode, right? So this is how the calculations of mode and median are done, and that's all for this class. See you in the next one.